Welcome to the Voices of Manufacturing with your hosts, Brian Salee and Michael Mullenberg, where business leaders across the industry share their unique challenges and insights.
It's almost like magic because it takes the learning process sometimes from weeks down to days, sometimes hours.
We want to help people within manufacturing and make them excited to come to work every day and go home safe to their family.
When you bring people in, they're anything but a machine. They're partners that can help you build your business. They can be your success if you treat them right.
And then you start having employees saying, when are you doing my machine? When are you going to come over here to my department? And now you get this buy-in.
This podcast is brought to you by Dazuki, the premier frontline digital transformation solution that allows manufacturers to standardize operations.
Michael, your time at 3M, were you ever involved in any projects that directly supported NASA, or are you aware of any 3M products that are in space and used by NASA or on the space station?
Well, actually, the most famous story is we had something to do with the heat tiles on the space shuttles. And back in the day, some of that high-tech material. And we also had various other government contracts and other aspects, usually very quiet, very locked down, but also very high-tech. Adhesives, materials, things like that were typically the focus.
Oh, that's interesting. So you guys had some work with the tiles. This was back on the space shuttle, Columbia. Very cool. Yeah, I was thinking about it. I know how many products you guys have produced over the years, and just seems like everywhere you turn is a 3M product. So I'd have to imagine there's quite a few 3M products used by NASA.
Yeah, there's a big group working with aerospace and obviously automotive and directly with the military. Again, mostly materials-based, adhesive films, coatings, things like that. Really an exciting area. I mean, it's the specifications sometimes drive you a little bit crazy, but it forces you to innovate and forces you to make sure that your quality is really where it has to be under those extreme environments.
Yeah, it is an exciting area, especially right now. We see all these space companies. It seems like SpaceX led this private industry, really got it going. And now we're seeing all these startups, and it's just a really neat time for space. But that leads me into our guest today. And I want to introduce Rodney Babcock. Rodney's the CEO of Next Intent. And what's really interesting about Next Intent is that they started off as a very small machine shop, and now they've grown into a top 20 supplier for NASA. And some of their work, they've contributed to the James Webb Space Telescope, the Mars Exploration Rover, and I'm sure there's many more that Rodney could share. But before we jump into that, Rodney, welcome to the show.
Thank you. I appreciate you asking me to be part of it.
Yeah, we're excited to have this chat today. And I guess one of the first things our audience is going to be curious about, Next Intent, it's a cool name. It sounds really interesting. How did you guys come up with the name for the company?
Oh, we tried a bunch of names and then they couldn't get through the state of California. And after 3 tries, that was the one that surfaced as one of our top contenders. So I wish there was a real special story, but the politics of getting the name approved through the state of California is interesting.
I'm surprised you didn't go with Next Attempt instead of Next Intent.
Yeah, that would have been a good one. Next Dimension, I think, was one, that I wanted to use, but that one was too close to some other name and they won't tell you what the names are. So
you got to keep guessing.
Yes. Our motto is we build really cool stuff, which was generated from us sitting around after we had built something that we pushed us right to the limits. And we went, well, gee, we really do build cool stuff. So now that's our motto.
Tell us a little bit about the company. I think Next Intent, I already mentioned you guys are a leading supplier for NASA, but what do you guys do?
So we're a job shop, machine shop. We have some engineering capabilities as well. We have an engineer on staff that has a master's degree from Cal Poly. So we do complex components for aerospace, defense, space, and national laboratories. We founded the company in 1996, my wife and I, and we currently have about 30 employees. We are using all of our skills and we combine everybody together and try to tackle the most complex projects because there's fewer people quoting that kind of stuff than there is the easy stuff. So we oftentimes are doing projects where there might be a significant number of no quotes. And we might have even no quoted it. And then the customer comes back and says, please, please, please try it. And then we do. So it pushes our company and our employees kind of, keeps them very interested because of the complexity of the work that we're doing.
I'd
Very
imagine so.
satisfying to work. Yeah, to work for NASA, especially.
Absolutely. Yeah. I could only imagine, the motivation that, you're working for this great organization that's doing really innovative things. I'm curious though, you mentioned your wife is the co-founder of the company. How did you guys get started? And why did you decide to co-found a company with your wife? Or did you guys work together previously before that?
We had not. I was working for a local company called Strasbourg that manufactured semiconductor equipment. I saw an opportunity for machine shops. It was hard for us to find really good machine shops for the most challenging parts out of titanium that, with flatnesses of 50 millionths of an inch. So that's the target market that we went after. I knew what all of our costs needed to be successful as a supplier to that company. So they were my first customer. And then we immediately started to diversify away from semiconductor because it's very steep climb and then a steep drop when things fall off. So I knew that going into it, and we looked at military and defense and NASA as a potential way to diversify. So we weren't tied to one industry or tied to one customer.
Was there any moment where, when you were working for Strasbourg where you said, I really want to go out on my own and build my own company? Or like, how did you get to that point where you decided I'm going to leave this job, which, I've got to imagine a consistent income coming in, you got stability, to go start something from the ground up?
Yeah, I think during the first I worked there for about 3.5 years. And during the first couple of years, it was very challenging as a manufacturing manager to build the infrastructure to move that company forward and to increase our capacity to build those machines for processing semiconductors. And I just saw that there was an opportunity. I liked working for that company. It was really interesting. I learned a ton of stuff. They were really smart people. And we had customers coming in from all over the world to help us be successful from the semiconductor industry. Learned a lot about process control because the expectation in that industry is every wafer that goes through the entire processes are all managed and fortified and verified so that you have the highest yield you can have, because each wafer back then, the saying was, be careful with that wafer. It's worth more than your house.
So that's where the roots and the kind of foundation around quality, which I imagine is obviously one of the most important things as you operate your business today. That's kind of where those roots, that foundation was set at the early years at Strasbourg.
Exactly. Process control was really an important thing. And the last third of my career there, I was the quality assurance manager working with the likes of IBM and other, really big companies in the US in the semiconductor. And I learned so much from just being open to admitting that I don't know everything and then I need your help. And those two things right there really opens things up for people to help you. I'm not afraid to admit when I don't know, but I can find somebody to solve the problem anyway. Just because I don't know doesn't mean I can't solve the problem.
And so you left Strasbourg, you started your own company, right? And then here we are. How many years later is it now? How long have you guys been in business? 27 years later, you guys are, somewhere in the realm of a top 20 supplier to NASA. How did you become a top 20 supplier to NASA? Like that's, we don't run into too many companies that are working in this space. And especially for this, as long as you guys have been doing it.
Yeah.
Sounds like quality focus had something to do with it. But what was kind of the evolution of the company that got you to this point?
Well, part of our diversification plan was to find other industries and other customers outside of semiconductor. So I found out about an opportunity at NASA Jet Propulsion Lab. I went down for an interview as a supplier and was grilled by half a dozen manufacturing engineers. And they could see that I knew what I was doing, and they could see that I would admit that I didn't know everything, and they liked that. And so they gave us some test parts to run that were ground-based programs. They don't usually bring on a new supplier and say, "Oh, here's a bunch of flight stuff." You have to kind of earn your stripes. So we did that, and we found that it was a great group of people to work with. They're very passionate about what they do. They're very smart. They make their selection on suppliers based on who's the best to make this particular part, and then have them quote it rather than just shotgun it out to anybody. And then they have a bunch of quotes, including quotes from people that maybe can't make those parts. So they're very selective in that process. And then it comes down to, the pricing and the delivery, and you have to be consistent with them. You have to try your best to hit your deliveries. And when you can't because of some reason, you have to share the bad news quickly and make a recovery plan. So we were good at that. And I always felt passionate about hiring people that are way smarter than I am on the machining. And we did some of that. I was a decent machinist. I knew what I was doing. I could program a lathe, but I was better at the leadership skills and the engineering skills and working with the engineers to help create a more manufacturable product. So that helps keep the costs down. That helps keep you on schedule. And one thing, when I say we're a top 20 supplier, I mean, that maybe is where we land with JPL. That's my own feeling about it. That's not a rating system that they have, but they keep coming back to us, and we have a very close relationship with them. We have worked with them on 4 different Mars missions, as well as many other projects that aren't necessarily as popular as all the Mars stuff, but they continue to come back to us for project after project. So the last one that we met with them was on the recovery mission to pull the samples from the Mars Perseverance Mars 2020 program, which is collecting soil samples. And then the next mission is to send a rocket to Mars, load those samples up, and bring that rocket back to US so that we can study those here on Earth.
Hey, Rodney, I'm curious about what the parts that you're making look like. Obviously they're precise, but are they small? Are they big? Are they sub-assemblies? Do you
All
make
of
a
the
lot of them,
above.
or are they limited runs?
They're very limited runs for the NASA side. You're only building one rover, so you might only need 2 or 4, 6 parts. So when we first did the Mars rover wheels, there's 2 rovers, 6 wheels each, 12 wheels on Mars. We built 52 wheels because they went through 7 different revisions and had to do a lot of testing, etc. So they're very thorough on the testing side at NASA. Many of the other things that we do are low rate production. We do vibration isolation flexures for almost every launch, which isolates the vibrations from the rocket so that it doesn't disturb the expensive payloads. Not only the primary satellite or payload, but the other smaller payloads that sit between the top of the rocket and the main payload on what's called an ESPA ring. That's what's driven the space market to explode, is that now you can launch things that are relatively small and compact and not have to pay for the full cost of the rocket with just one big payload on top of it. Now there's multiple payloads. When SpaceX launches Starlink, they're launching 51 satellites per launch. Significantly lower cost than the same technology 25 years ago would have been 1 launch, 1 satellite, 1 launch, 3 satellites maybe.
So a big part of your work then is protecting that payload and all the components that go around that assembly.
Exactly. And we use a 3M. Our customer uses a 3M product that's a viscoelastic layer that helps and the dampening process for these vibration isolation flexures. So we've built over 10,000 flexures since we started the company. That's one of our key elements that we're experts at. And our customers would be Moog Space and Defense, Ball Aerospace, Jet Propulsion Lab, Lockheed Martin, Boeing. Pretty known companies that know what they're doing most of the time.
And Rodney, as we think about your company, and I'm very interested in digging into how the company evolved and like what systems you had to put in place, technology, hiring, all those things. I want to dig into those. I guess maybe the first one is technology. I think, some of the work that you're doing, you're building parts that have never been built before, right? I think you've mentioned this before. It really stretches the capabilities of the shop and your employees. What were some of the early investments in technology that you guys made because you knew you had to have, this piece of equipment or this piece of software in order to work with some of these really innovative companies?
Yeah. So on the technology side, one, we started by buying very high-end machine tools. We didn't just go with the cheapest machine tools and then, we'll upgrade later. We started with a Japanese machine tool builder, Hitachi Seiki, beautiful machines. The original machine that I bought 27 years ago, a friend of mine has, it still holds tolerances of 50 or 60 millionths on position. They're great machines. The second thing is investing in quality equipment, quality assurance equipment. So as soon as we could afford it, we brought in coordinate measuring machines and gauges and all kinds of high-end measuring tools. And then the most important part is the people to run all that stuff. I mean, the equipment and the building is easy compared to the human element of people that can, work to our flow chart, create process control from start to finish, and then create an end item data package, which is basically the certificate of compliance package that matches up and captures every single element from where the raw material came from, all of the dimensions that we collected, all of the outside process certifications, and then roll that all up into a data package that's very readable and organized and thorough, because they can't use the parts if you don't have all of the quality documentation. So some of our end item data packages now have gone over 300, 400, 500 pages. We just finished the red camera assembly for the Giant Magellan Telescope, and that package is 1,500 pages long of data.
Wow.
That was an 11-month long project.
Wow. Yeah. I've always heard there's a good saying I've heard from someone else in aerospace, which is for every part we produce, a pile of paperwork this big, essentially a file cabinet's worth of paperwork. It sounds like that is actually true.
That is very true. The other saying I hear is that the paperwork has to weigh more than the part. So we had a small flexure that we did that was part of the James Webb Space Telescope, the actuators that actually shape the mirrors. So a single part that we produced had a 1/2 inch thick of paper, and the parts fits in the palm of your hand. And it's high risk. We do stuff that's high risk, and then we try to find ways to lower the risk by being smart and applying process control and learning what does the data tell us. That's difficult, and a lot of people sometimes will overextend themselves. When we got the order for the Mars rover wheels, the wheel wasn't even designed yet completely. We had a rough drawing of a round part, rough machined, heat treated, and the design wasn't even completed, but they were smart and that they knew they had to get something going. We had to build, we had to buy 60 pieces of material. Started off weighing 60 pounds, and when we were done, it's 2.25. So that kind of tells you something there that, we're removing sometimes 95 or 96% of the material that we start with in the subtractive process.
Yeah. Well, going back, Rodney, to to
Right,
the
Brian.
investments, you mentioned you invested in the best equipment, right? That was, you weren't going to buy cheap equipment and upgrade later on. And
Yeah.
then the second thing that I keep hearing is really around process control and having a good system in place to make sure that you're meeting the quality standards that are necessary to deliver a part that's within spec. I imagine process control is, one part technology and then one part human. How did you train your employees to have this focus on quality? Did you hire people from outside that already worked in the industry? How did you go about, I would say, establishing a culture of a focus on quality?
Um, yeah, we established the policies. We have flow chart that kind of is the master document for the company that I got from a guy from the semiconductor industry, from Texas Instruments. He was brilliant. He gave a great presentation, and I saw this flow chart. I went, "There's the flow chart for my company. I haven't changed it in 27 years." And so we bring people in, we interview them, we see what kind of work ethic they seem to have, and then we just start training them and we put them through classes. We've held, I think, three different geometric dimensioning and tolerancing classes for where we brought somebody in from the outside and we've invited other companies to send students to. We've done that three different times in the last 10 years. And we continually work with our employees to find ways to collect all the data. We've done a lot of it just collecting the data in spreadsheets and then rolling all those up into the end item data package. Each machinist has their own laptop to collect the data and to manage all of the files that they need to manage, including the tool paths and the solid models. And if they have to create a fixture for themselves, they're learning some basic CAD CAM functions using Autodesk Fusion 360 as a way to become familiar with programming and learning programming on their own within a community of Fusion 360 and within our own internal community of different guys helping out that have more experience helping out the younger or the newer employees to learn how to do these things. I don't want my 5-axis programmer to stop programming on something that's super intense to make a fixture that somebody else could program and do and to keep that project going. We have an unbalanced level of QA people here for a 30-person company. We have 5 people full-time in QA because of the intensity of the work that we do and the amount of data that we have to collect. The last thing is that we've also now invested with a company called One Factory for quality assurance, documentation, collection of the data, management of all of our gauging. Think of it as a big database that allows us to pull a lot of things together, know which tools measured the parts, put it all together into a big, huge COC end item data package. It's very effective, really good software, well-managed company. The CEO is involved in telecoms where we're talking about improvements that we would like to see. They're very active in making all that happen.
Could you also elaborate a little bit on your continuous improvement process? So not only the people development and the onboarding and training and stuff, but also process improvements, workflow improvements, even improvements to your documentation system. What does that look like?
Okay. One of the things that we do for all of the employees is they have a job status board at their machine. And we involve the machinists in helping us predict our productivity. When is that job going to be completed? We need to know that. Are we on schedule or off schedule? We might have underestimated the time it takes to make that operation successful. We don't want the employee to feel like it's their fault. It's the company owns the process. So that's the key thing is that let's get rid of the blame and just say the company owns the process. Everyone's involved in making the improvements of it. We ask all the employees to contribute to what do you think the best setup time if you were going to run this job again? What's the best cycle time that you were able to achieve? So when that job repeats, we've got knowledge from the data that we've collected. So we have a very good ERP system that collects the data. And then we have the input from the employee that just ran that operation. He's the expert on that operation. He knows how many parts a day or a week or per hour he can get. So we solicit that, they put it into their time card data, and then we can review that job, a day later or a year later or 2 years later, and know exactly how many minutes went into every operation, how many minutes went into setup, how much tooling we consumed. Very, very good system, be able to look backwards and see what we did. So that's one of the opportunities that we can use to leverage the knowledge of what we were able to accomplish building Flexure A. And now we have Flexure B that's similar, but not the same. But we can use the data from that Flexure A and apply it to Flexure B. Even during the quoting process, we're looking backwards at, well, what did we do last time? And did it work? And is there notes from the machinist that, hey, I think I should fixture this differently, or this tool was the best tool for finishing rather than the one we started with. So it's really an active system relying on good communication and a good feedback loop without anybody feeling blame when they have to give us feedback that it's going to be 5 days later than what we planned to finish this operation. Well, we estimated wrong. Didn't run like we thought it would. Sometimes that just happens.
That seems like in the quantities, you guys are low volume, right? You're not making a ton of these parts. One of the biggest challenges is, I imagine, quoting and then quoting a part you've never built before, and then it taking longer to build than you expected. And I guess the question that I have is, what's the future opportunity for you there in terms of, you already mentioned you're using some of that data that you're collecting from the machinist. Hey, this didn't go well, or I would set it up differently this next time. What's the opportunity to use more of that data in future quoting processes? Are you guys already pulling that data in using some sort of software solution, or, how are you
No, we're not
reviewing that data?
We're just reviewing it based on the part. Either it's the exact part number that we're quoting over again, which some of our customers have that. We repeat every year. We have a contract with Northrop Grumman for a bunch of missile parts, and they're pretty much the same parts over and over. So the only thing we're doing is learning from what we did last year, applying it to the next year's quote. And if we can, and we can save some money to the customer, boy, do they appreciate that. Sometimes we can't reduce the cost, but we can hold the same cost, even though our costs might have gone up. So customers are always driven to find a lower cost point. Or the other way I like to look at it is find the best value point, which might not be the lowest cost, but it's the best value because the supplier is somebody you can count on. So that's the relationship we have with Northrop Grumman. We have about 8 part numbers that we are single source. We're the only ones that make it. They're really difficult parts, and it's relatively low production, 320, 350 a year. Now you compare that to somebody that's doing 737 parts, and there's multiple manifolds per airplane, and they're doing, 200 a day, 300 a day, 400 a day. Their risk is way different than ours. Their risk is if they have one little process control thing and it takes 4 days at 400 a day, you've lost 1,600 parts in 4 days. For me, I'm doing a production run of 320. I'm not going to lose. I'm not running at a rate that's that fast. But the parts that we're doing are extremely delicate and intricate and require a huge amount of process control. The other thing is to eliminate complacency. Just because we've done it before doesn't mean that we can repeat it again and that things are going to be perfect. If the fixture wears out a little bit, if you have some gauging issue, or you have one tool that's maybe not set properly for finishing. So we're always diligent on being careful to not become complacent on something that we've done in the past, because it's still a really difficult part to make.
Yeah, you're constantly fighting entropy.
Yes.
Things unravel and yeah, and well, and Brian and I talk a lot about the daily management system. It's really interesting to hear you describe how you collect the data and you use that, backward looking, forward looking. And that's really a variation of this daily management system on a very unique type of business, which is great. The tool and the method still works, even though it's low volume and high precision.
Yeah. So on the giant Magellan telescope that we just finished, 46 part numbers, most everything's made out of Invar, and it requires rough machining, stress relieving, semi-finish, stress relieving, finish. So there's 3 opportunities to scrap out the part in every setup and in every operation. So you have that pressure, and then just the length of time it takes to get all of this done. And then you get right to the end and we send it out to an outside process for cleaning, and they do the wrong process and put parts that have 40% iron in a passivation bath and almost destroy $300,000 worth of parts in 2 hours after 11 months of machining. And then people wonder why I'm stressed out. Well,
Wow.
it's a lot of stress, and you're managing this work in process inventory every step of the way. Every time you ship it, it has to be in indestructible packaging. I mean, just the packaging of this assembly alone is incredible how much effort goes into just the packaging side.
So you guys are designing packaging as well then, because these are
Yeah.
one-off type of components. What type of packaging are we talking about here?
Well, in this particular one, we assembled everything in a clean room that we borrowed from Maverick Space Systems here in town. And then we had to bag everything, bag it all up. So it's all done in a clean room, all assembled, all zipped into a bag. And then we placed that bag into a cradle that we built out of wood that has 2-inch foam that's cut to the same contours. This is a mostly round features. And then set that into that wood cradle, and then lift the wood cradle up into a big plastic Pelican type box. And then that's all, secured with big straps and everything. And then we put that box into a wood crate, and then that'll ship via FedEx Custom Critical. So the only thing in the truck from here to Harvard will be that one package.
Wow. Well, Rodney, one thing I'm always curious about with companies like yours, you've got ISO, 9001, you've got AS 9100. There's a lot of things you have to do to, I guess, remain in compliance, right?
Correct.
Do you have a dedicated person focused on that? I know you mentioned you have 5 people working in quality. Do they kind of all share that responsibility? How do you manage these programs?
Yeah, the quality manager is a really smart guy, Cliff Miyamoto. Known each other for 10 years. He came on board about 3 years ago. And he's really good at managing those and running through and preparing for the audit and doing the audits. So we know that process really well. And we take the audit process really seriously, because if you run your company that way, then you have fewer issues, fewer corrective actions, fewer returns that you have to do. So that's a key element for us, is to educate everybody and run it that way. So he keeps up on all of the latest things on the standards. We've been through enough audits that we kind of have that all figured out. So we had an audit, couple of customer audits this year. Even though we're certified, they still have in their documentation that every 2 years we need to come out and check up on you. So we had Moog come out here this recently, and then Amazon Kuiper project, which is satellites similar to Starlink. And they're in the early stages of that process. So they put us through an audit, not because we didn't have because they were having problems with their entire supply chain. They just went, well, we're going to go across the board and just audit everybody. We got 100% on that audit.
What is that like for the employees? Hey, we've got this one of our top customers coming in to audit us. Is it just, kind of old hat, they're used to it? Or is it something where, you can kind of feel I don't know, I wouldn't call it stress, but you can kind of feel the need to prepare? Like what is that like for the employees?
Yeah, there is some stress because they all feel like, well, what's going to happen if I get interviewed? And, we just coach them. You tell them what you know. And if you
Yeah.
don't know, then you just say you don't know, because what they really know best is how to run that machine and how to run that part. And they're not thinking about the quality side of it. Yeah, they were trying to make a quality part and record that data. So again, we kind of come back to, if a guy says, I don't know, and the auditor says he should know that, then we have a gap that we have to train to. And that's how we take that data and we train them. And then we give that customer the feedback that, yeah, that was a good outcome. We found that we had some weaknesses. And there's usually a couple little things that show up, that are not a write-up, not a major finding, not a minor finding, but FYI, I've been to other places similar to yours. Here's what they were doing. It seemed to work for them. Check it out. Not a requirement, but really good heads up, smart data collection. The more data, the data tells you what to do. If we had major findings every time, then we don't have much of a system. But we get through these things. We almost never have any major findings, and even kind of rarely have minor ones now. So we know the game, but we're serious about playing it. There are some companies that just go through the cert process, they get the certification, and then they go right back to how they were doing things. And then a year later, they get the next audit and they prepare and they kind of just get through it. It doesn't match up with my philosophy. I tell people,
Yeah.
I didn't get killed today because I verified before I crossed the street that there were no cars coming. And you could use just the verification process alone is what all of this quality. We tried to make a 2-inch hole. We verified that it was 2 inches. Done. Now, if it's 2 inches plus or minus 20 millionths, it's going to take a lot more effort to measure that hole than plus or minus 10 thousandths.
What I take it from you here is that you guys are routinely going through these audits, customer audits, ISO, AS9100, whatever it is. The team is always prepared, it seems like, because you're actually practicing. You're actually doing what you say you do. You're not just checking the box to comply. And so that's kind of like a muscle memory that's built into the organization. I got to imagine that helps when it comes to new clients coming in and evaluating your company, right? They see as they come in and evaluate before maybe they embark on a project with you. Is that pretty common for them to come visit and see how you guys work?
It's hard for them to see that element of the company. Is that how much does that machinist know about the quality management system? So we've seen that there's a bit of a gap on the knowledge of the QMS versus the knowledge of doing their job. And so now we're trying to marry those together more closely. Here's your job description, and here's the elements of the quality management system that you are most intimately in contact with or affecting, rather than they don't need to know what the shipping requirements are for the part. They just need to know, while I'm making the part, how do I gauge it? How do I QA it? How do I assure that the process to make the first part through the 10th part was solid, and that we collected enough data, just enough data to prove that to our customer. Our customers, most of the time, are not that educated on the fine details of running a machine shop. They don't know what the risk is. They don't understand. They think if you put a tool in a tool holder and push the button on the machine, that the machine just magically does exactly what you say. No, it doesn't. It's not a 1-for-1 relationship. If I make an offset change on a lathe of 2/10,000ths of an inch, I might get that result when I measure that part, but I might not, because maybe the boring bar or the tool holder is actually bending a little bit because we're cutting a really tough material like Inconel or 15.5 stainless that's been heat treated. We machine a lot of stuff in a heat treated condition because while it's harder, it creates better chip control and we actually get a better surface finish and a better part. So that's knowledge that we just built over time to be able to figure out what's the best recipe and then manage that recipe as best you can.
Rodney, does some of that expertise, I mean, that was a great example of how you process the material and all these variations. Are you feeding that back to the customer in even affecting their designs to make things more machinable, more manufacturable?
Yeah, we do. We get very involved with our customer Moog Space and Defense on the flexure design. So we are
Mhm.
actually part of their design team. When they get a concept, they'll throw it by us and say, how manufacturable is this? We'll point out places where it could be improved if they can make the change. And we understand sometimes they can, sometimes you're constrained by the customer and you can't. So it's a good feedback loop. And with that customer, it creates a very smooth transition from concept to engineering development units to production.
Yeah.
So, like
Sounds
right
like
now, we're quoting flexures to protect the Roman Space Telescope during launch. They're really pretty big flexures, 8.5 by 16.5 out of titanium that's 1 3/4 thick. They're really challenging parts. We got to hold down to just a couple of thousandths of an inch on the thickness, on the profiles and everything. Yeah, there's other machine shops that could make this part, but there's not other machine shops that have the experience of making a part that basically is a custom designed spring and how to deal with all of the characteristics of the raw material, titanium in this case, and how it's going to want to move away from maybe the ideal tolerances that the customer is calling out. So we have this great feedback loop with them where we make some stuff, test it, give them feedback, and then they might even adjust the size and shape of the flexure a little bit based on that. Other customers, it varies. It varies with how long the relationship is, or it varies with the age and generation of the engineers we're dealing with. The newer millennial engineers sometimes think they know more than they actually do. And you actually can't find everything on YouTube. Sorry. And they get hurt feelings when you grade their drawing and say that's not manufacturable. They actually want to file a hurt feelings report.
Wait, you mean I can't learn how to make rocket parts on YouTube? What is that what you're saying?
Yes, that is correct.
But
Now,
Wow.
really, what I'm also hearing here, though, is like you guys are really like the R&D department for a lot of these companies. These are parts
oh
that
yeah,
they're not able to make internally, and they are 100% reliant on you for that feedback. Like that's critical IP, right? That's very valuable to them. I imagine as that feedback is, worth so much money. I'm sure.
it is. And yet, our intellectual property is not valued the same way that engineering of the design would be. Our
Yeah.
intellectual property is creating the recipe to build what the engineer designed to solve an engineering problem. And there's more than one way to slice it and to make the part. And there's a lot of great machine shops out in the world, some that are way better than I am at doing what they do. So we've carved a niche for ourselves of highly engineered, kind of complex, 5-axis, and then tough materials. I can't drill 4 holes in a piece of plate of aluminum for as cheap as a guy that has a machine in his garage, and I never will be able to. But he can't make the giant Magellan telescope camera body either. So somewhere in between those two ends of the spectrum is, we just try to keep carving out stuff like that. We've gotten a lot of work from doing optical housings, optical benches, optical based work, because the optics world is a different world for if you're making telescope stuff. Everything's driven by the astrophysicist and what the light bands are going to do and how do we divide those light bands and how do we examine all of that. So the tolerances on some of this stuff is down, well below thousandths of an inch with multiple features in one housing that are all less than a thousandths of an inch.
Yeah. And I think that the takeaway too, I think for, anybody who's got a machine shop and is looking to develop a specialty, right, is the longer you develop that specialty, the longer you work in that area, the more, like you're saying, intellectual property you developed in terms of how do you actually manufacture this part. And that becomes critical. I'm sure that's helped you guys win a lot of new business. You've worked with all these companies and similar applications. Do you continue to win new business because of that reputation?
Absolutely. And one of the challenges is that some of the stuff we do is classified programs. I can't show a picture of the part. I can't show something to Lockheed Martin that I did that was for a secret program for Ball Aerospace, because then Lockheed's going to go, well, why are you sharing intellectual property? Why are you sharing? I can tell them what the program was and they'll go, oh yeah, we did something on that program too, but I can't show the part. It's a black hole as far as marketing and advertising. At one point, we were building components for the inside of the airborne laser, which was a 747 with a laser inside of it and going to shoot down ICBM missiles with a gun that mounted on the front of it, a laser to shoot it down. We couldn't show anybody the stuff that we designed and built. We asked Northrop Grumman, who was our end customer, can we show some of this stuff? No, you absolutely cannot. And then one of my engineers goes, well, he found a picture of the whole inside of the laser on a Chinese website. So, I mean, I can't advertise it, but we can look it up on the internet and find a picture. So, I mean, it's just the way it goes. I think the other thing is that to attract talent and maintain talent is that the niche that we have carved out is way more challenging than somebody standing in a machine running the same part number over and over and over. So we've been able to attract really good machinists that kind of learn from other shops that have just different types of business. They're not worse than we are, better than we are. They're just different. And everybody has their own business plan. And so we've been able to attract really smart machinists that got a lot of their education by working elsewhere. And then they come here and it's a matter of learning our way of doing things and our processes. And then they're bringing in some new ideas that we didn't even think of that came from these other companies. So it's great collaboration on a daily basis. We're collaborating to figure out and solve problems.
Well, Rodney, as we come to a close here, one of the things I'm most curious about, there's so much innovation happening right now, especially in manufacturing when it comes to hardware, software, getting those two systems to work better together, machine tools, a lot of new innovations there. What are you most excited about in terms of advances in your industry? What are you looking forward to most?
Well, I think that the Industry 4.0 wave that we're seeing is going to continue to allow us to collect data easier and manipulate and look at that data to teach us and improve the process control. So for us, it all feeds into the continual improvement loop that we have for everything we do. It kind of drives my guys nuts, but I continually walk around and see things that needs improvement. This needs improvement, that. And we all start doing that. And we do it in a way, again, that comes back to it's the next intent way. It has to be our best practice at all times. Everybody that comes in the door from outside of our company is an advocate for us based on their first impression. One of the best customers we ever had came from a tool supplier, a local tool supplier and he got the call. Who's the best machine shop in San Luis Obispo? I might be moving my company there. And he hands down said, well, next intent, they have it together. And that was a great relationship. He sold the company to ITT, and we've continued that business ever since. He was one of our early customers in 1997. Went to Cal Poly, never moved the company here, but boy, we had a great relationship with him. And we did 10,000 fuel pumps for the B-52 program over 6 years. B-52s are been around for as long as I have.
Time. Yeah.
I love the fact that you're seeing that benefit, that Industry 4.0, and it's not just a buzzword or whatever. You're actually seeing benefit from and future benefit for sure. So that's incredible.
Yeah. I'm not trying to advertise software, but just a good example. Autodesk Fusion 360 cost me $400 a year. Comes with a complete CAD package and a complete CAM package. We've run that CAM package, and I don't think we've had but 1 or 2% issues with not being good G code to run the machine. I've got $25,000 software where I've had significant problems with and had to have them rewrite some code and fix some things. So the value is really there with some of these companies that are really pushing hard to listen to what our machinists need. And they've created a community where they have a great feedback loop and they're improving software all the time, just like you guys do with Suzuki.
Rodney, this has been a fascinating conversation, learning about your guys' niche in the manufacturing industry. Appreciate you coming on the show.
You bet. Thanks so much for having me.
Very inspiring. Future looks really bright.
Thanks for joining us on another episode of the Voices of Manufacturing podcast with Brian Salee and Michael Mullenberg. This show is brought to you by Suzuki, the premier digital transformation solution that allows manufacturers to standardize operations. Our website, where you can listen to our episodes and find tons of helpful resources, is Suzuki.com. Sign up for our monthly newsletter so you'll be the first to know about new episodes. That's Suzuki.com, and join us in creating the front line of the future.